All right. I believe the next item on the schedule is the panel on contributing to CVXPY. So if we can invite up the panelists. William Zhang, who you heard from earlier today, has been a longtime CVXPY contributor who started as, I think he started as a Google Summer of Code contributor. And Nikhil Devanathan did his first PR a month ago, or two, maybe 2 months ago now. And so they're going to talk about this. Yes, you guys have a microphone. And I've got my questions pulled up. Let me fix the camera so we can see everyone. Reset. Okay. Maybe you guys should scoop here. If you guys move forward to this side, I'll do one screen seminar. And then maybe you guys push it back a little. Okay. Okay, awesome. So why don't you guys introduce yourselves?
This is what? Oh, yeah. Okay. Hi, everyone. My name is William. I started contributing to CVXPY around the end of 2023, and I did a project with Google Summer of Code, and I was mentored by Philip, as presented this morning. Yeah, I've been contributing since then, and it's been a great experience. So.
Hi, I'm Nikhil. I'm in Stephen Boyd's research group. I am a longtime CVXPY user, very recent contributor. I made my first PR in December that got merged in.
Awesome. William, why don't you walk us through the standard process to making a change to CVXPY?
Yeah, so I mean, usually we have like issues that we put, and sometimes we try to label them. We're trying to keep doing a good job of that, and so some will be labeled good first issues. So usually you would find an issue for you, or sometimes other people have specific things that they want to work on. So the standard process is you make a change, make a pull request, and then have message one of the maintainers and have them have a look, and then after a few back and forths, we usually can merge the code.
Nikhil, do you want to talk concretely about what you experienced?
Yeah, so when tensor support got added to CVXPy, I wanted to solve a problem that used the new tensor variables. But I needed to do basically like some matrix multiply type stuff with these tensors. And so I needed to do a reshape product sum. And in NumPy, I would do this with like a NumPy einsum, so I could work with indices. But in CVXPy, there was no einsum atom. So I looked for open issues or open PRs that we're talking about einsum. I didn't find any, so I decided to just go ahead and start implementing an einsum atom. I also wanted to contribute to CVXPy for a while, so it was a good first opportunity, I guess. And so I looked at GitHub contributing to open source projects guide and the CVXPy contributing guide. I forked the repo. I used the dev container for my development environment, and then I just started, building code and tests in parallel.
Awesome. And then so William, you mentioned that there were kind of good first issues from your contributors. Do you want to maybe elaborate a little bit more on kind of what type of issues tend to fall into that category?
So one common thing that some people do as their first issue is to add new atoms to CXPy, and there's actually 3 ways to do that. So one way is to kind of represent your new function as in terms of other atoms. So for example, sum of squares is calling quad over ln under the hood and with the denominator of 1. And then another way is to kind of figure out the new canonical form. So represent this function in terms of existing cones, or maybe even developing new cones potentially. And then the last one is to write an internal function that implements the atom in the backend. So those are the 3 ways to add a new atom.
And the last one's restricted to affine atoms, right?
Yeah, the last one is restricted to affine operations. Yeah.
Nikhil, do you want to elaborate a little bit on kind of you obviously started with an atom. Do you want to talk a little bit about that?
Yeah, so when I started building out the Einsam atom, my first instinct was to go with sort of option two and start building out like a affine atom class that, well, really an Einsam class that was an affine atom, and then basically describe, the various properties of this atom, and ended up being quite complicated because I would need to figure out how to implement like a gradient of Einsam, simple mathematically, maybe a little less simple to implement. Um, and I ended up running into a lot of trouble with this approach. And I talked to William, I talked to Parth about this, and I really got some of this feedback like way later than I should have in hindsight. I should have just been more willing to ask sooner. And they sort of directed me towards option one because Einsam is sort of intuitive in terms of reshapes, transposes, products, and sums. These are all well-behaved CVXPY atoms already. And so I started actually, moving towards option one and building Einsam in terms of existing atoms.
Yeah, I want to hammer home the point. A lot of pain is saved when you reach out to us early and often. We're happy to look at a draft pull request that doesn't work at all and give feedback, and we're happy to just chat on Discord about how to approach a problem. Okay, William, the internal code base and kind of core algorithmic parts of CVXPy are pretty complicated. Do you have any projects on the horizon to help with that?
I guess we always like are looking to improve the performance of the backend. So right now, I think Steven has added a new backend, and we also should do a better job to document the internal code base. But yeah, I think that's one thing I have in mind.
Any like draft documents that you want to mention?
Yeah, we are also working like a paper that describes, I guess, in a more unified way, the whole like what CVXPy does internally. So that could help the new contributors that are interested to like very deeply in the internal code base.
Awesome. Do you want to talk a little bit about kind of the question asking that you did at the start? Because we didn't have the backend paper at the time, and frankly, our documentation was much sparser than it is now when we started. You want to talk a little bit about how you kind of really got engaged with learning the code base?
Yeah. So I was kind of fortunate that I was like assigned a project, and I was like paired with Philip, my mentor, and I could ask him questions directly. But I think other good sources to ask questions would be either to open a GitHub discussion or like send messages on Discord. And yeah, like Parth said previously, like try to reach out to us early. And I think that helped me a lot because I had a lot of kind of stupid questions at the beginning, but since I was it was less of a serious environment, I could just ask questions freely. So yeah.
Nikhil, what's one thing you wish someone had told you on day one?
Yeah, so biggest day one thing that I wish they had told me, open a PR early. I wanted to wait until all of my tests were passing until I opened the PR because I figured, I should open a PR and then it'll be very easy to merge in because everything's already passing and it'll be a straight shot. But really what it meant was I spent a long time sort of just struggling to fix issues that if someone who maybe knew a bit more about the internals of CVXPy looked at, they could really sort of help me and accelerate the process. And so I waited a bit, maybe longer than I should have to open that PR. And so I think that opening that PR early, as soon as you have like, something that just demonstrates maybe the core idea is great advice.
Last question from me, and then we're going to take the audience question that we just got in chat. William, you can probably answer this best, but do you feel like you need a PhD in optimization to contribute meaningfully to CVXPy?
Yeah, obviously not. But I mean, I started as an undergrad. I think historically, a lot of PhDs have worked on CVXPy. I guess maybe they have not. They're procrastinating on their research. Maybe that's one of the good reasons. But yeah, I started as a undergrad, and I come from a computer science background, and I think the code is really I would hope that it's well organized. At least that's what I thought when I started. So it's like you can really like work on one part of the code base, and not really you don't need to understand the rest of it. So it's really like self-contained in some sense, and I think I could really like contribute something meaningful like without knowing too much about optimization. Just the basics were already enough.
Awesome. And then I think Stephen wanted to answer the question from chat, and I'll let you summarize the question as well.
So Michael, Grant was asking about our policy or our approach to AI-generated contributions. This is something that's definitely on our minds. I guess I was a early Claude Code user. I've been using it for a long time. I would not have committed any of that code to CVXPY until around, I forget, whenever Opus 4.5 came out. It actually was at the point where, okay, this is actually quite good code. And so there was a period of sort of going nuts with, because there were things we needed to do. Like we had to get a lot of features out related to ND arrays and the new backends, where it was just not really possible with the manpower we had, and we'd sort of been blocked for a long, long time. So that was, I think, very exciting. But I think we have started to think more about that this is two-sided, and it does change the contributor dynamic a lot. And we don't have an answer now, I would say, in terms of what our policy is or how precisely we're thinking about this, but it's definitely very much on our minds. Anyone else?
So, I mean, like, particularly notable last kind of week has been matplotlib being very disrupted by kind of automated code generation and stuff like that. And so we have not experienced that yet. So for now, we've been relatively open to kind of people using what they want to use. Our perspective is we appreciate knowing how much, like, when people are using generative tools, that helps us understand reviewing. I find that knowing whether somebody's using Claude Code has been really helpful in figuring out how I'm reviewing a project and where to focus on. And so definitely kind of disclosure is our kind of top priority now. And we're just kind of, I don't know, we've gotten a lot of features done that have been on the to-do list thanks to Claude Code. So we're definitely like open to seeing where this goes, but also at the same time, we're just being responsive to kind of as norms shift and as new technology pops up. Okay, Stefan has a question. Regarding documentation, maybe a more thorough explanation of how DPP works, when it doesn't work, and how to work around issues would be great. It's one of the parts I have struggled with. That's a fantastic suggestion. Definitely, we'll put that on the to-do list. All right, we're almost done with this panel, and then we're going to move on to the talk back. But one thing I wanted to flag is the easiest way to contribute to CVXPY right now is a project we're launching tomorrow called Solver Benchmarks. It's at CVXPY/Solver Benchmarks on GitHub. It's two phases to the project. The first phase of the project is we're inviting everyone to contribute kind of representative problems of what they're using CVXPY for, so that we can have a better kind of understanding and sense of what problems people are solving, and so that we can benchmark those exact problems to make decisions about how we are deploying solvers. And so that's just asking people to write a CVXPY model in a single file that solves a problem that is similar to what they do. And then that's going to go on for probably a month or two. We'll probably be soliciting these problems. And then we're going to move into the second phase, where we're going to ask everyone to run the full benchmark suite on whatever computer they actually run CVXPY problems. And we're going to gather basic information: CPU version, number of cores, amount of RAM, operating system, what linear algebra libraries are available, kind of basic stuff like that. It's all in a plain text file, so you can see what you're sharing with us. And then we're going to just get benchmark numbers on how long each solver took to solve each problem. And we're going to use this to adopt a much, much smarter, hopefully, algorithm for dispatching to solvers. because we know that like Highs is apparently much better on larger problems than Clarabelle is, and so we should probably be deploying to that in some circumstances. So we want to really be a lot more intelligent about how we're approaching this, and so we'd love to get concrete data to guide us. So if you even have the most basic interest in helping us out, go to CVXPY/solver benchmarks and give us a hand. All right, thank you.